Hi, can you hear me? Can't tell if my volume's loud enough. Cool. So today I've got my Rode shotgun mic on instead of the little condenser mic that I used last time. So I'm just using the mic that I normally use to record my videos. So it's kind of up here above my head. Hopefully it's out of shot. And this week, kind of going to be doing. It's kind of been an ad hoc stream. I'm going to show you a bit of behind the scenes of how I put the video together, and then a bit of the prep for the next video that I'm going through, and then we might go through and see where we got through on the last live stream, which was the elmification of the MonoGame stuff. So let me get rid of a blank screen and grab something. So I've plugged in my SSD drive and it's going to bring up Final Cut Pro, which is a program I currently use. I'm currently thinking about using and learning. I've been doing a course on Adobe Premiere. I seem to have quite a few problems with Final Cut Pro because I'm really one of those people that crashes any software. So I want to give you a feel for what is involved when I make these videos. So bring this up full screen. So this is kind of what it looks like when I make my videos. I mean, this might or might not be something that you might be interested in, but I thought maybe this is something that would be of interest to see how it's built and comprised. So in Final Cut Pro, you have this thing called a magnetic timeline, and this is what my last video looked like. So you can see every single piece of footage that comprised the video. You can see these things here are my transitions, and you can see the waveform for the sound. This is my voiceover clip, and you can see the background music. You can see the intro transition where it spins in right at the very beginning. The swirl transition in and effects and things like that. So there's quite a lot of different pieces that make up this. And you can also see this is the collection of all the clips in the video. You can see there is a shit ton of media that creates the clip. From my intro footage through to the sound files, Rabbit and Heavyweight. These are YouTube open source music. And then you've got my video clips. These orange pieces on here, I don't know if you can see them, but they signify pieces that I've used in the video. So you can quickly see which pieces I've used. You can see these sections, there's like little pieces cut out. And this kind of signifies all the pieces where I've kind of cut out pieces of the video or mistakes and things like that. You can see these recorded screencasts that I've made for the Mega Drive consoles, which are these parts here. When I recorded these, I put on a CRT simulation effect, so you can see there's like a rounded CRT effect, and there's actually simulated scan lines and some slight blooming. So you can see you can see that easy. Go back a few frames. You can actually see on the white of the text here there's like CRT simulated blooming. So it's kind of doing like a Gaussian horizontal blur to simulate the shadow mask of the electron beam hitting and blurring. So if we go through more of the video, you can see I've got the intro music that fades out, more music fades in. This is like -40 dB, so it's quite quite quiet in the background. You can see these are the transitions between the videos. I'm even zoom panning left and right, which is these stylistic transitions where it'll swirl left and right. I tend to use the same types of effects in every video to try and keep them having the same feel. So I normally use either glitch effects, where it glitches left and right, or glitch strobe effect, or I use some of these, I think these are called quick blur transitions. I'll make some of the transitions myself. If there isn't one available that I can reuse, then I'll build my own from scratch using a product which goes with Final Cut Pro called Apple Motion, which is how you design the transitions and effects and things like that. So you can, this one here, I tried to time the transition of this so that as there's the last explosion going off on the screen, it kind of zooms in and punches straight into the code. So I thought that was a nice thing. These are the sorts of things why sometimes my videos take longer to build, because I'm messing about with small details like this, trying to get it to look just right. And you can see these are just me doing the voiceovers, doing the screencasts and things like that. These parts are the titles. So these are the, I've got like a red title, so that will slowly swirl in to kind of highlight a piece of the code. You can see it there. I kind of built a lot of these myself for different things. I've got vlog titles, I've got my intro, text intros. These you can kind of drop onto the timeline to create the descriptions of different elements. I've got my rectangle effect that draws on bouncy animated arrows with vignetting effect on them, animated bullets that glitch in and things like that. I think I've got some more as well somewhere else. That was my title sequence, which I created with Motion. That's kind of got multiple different effects. There's a strobified text in effect, and then there's glitches, which applies a, what does it apply? It applies a displacement effect, which is kind of like blocks of color which displaces the video. It's kind of like bump mapping, but for video. It creates a displacement. So there's a video playing alongside the main title sequence, which displaces the text displayed on the screen. So you get these displacement effects. And also the whole thing is surrounded by a CRT simulated effect. So you can see the scan lines on there, and there's some slight blurring, and there's some slight waviness to simulate a bad raster effect on the screen. I think there's a ton of cuts in here to do all sorts of different things. Each segment is kind of cut to shreds to kind of reduce the amount of time you're staring at things which don't matter. And we've got various more transitions here. That one was a point swarm zoom, so it kind of like does a Gaussian blur on the pixels in a certain direction. So it kind of it's like it simulates motion blurs if you're going into the picture. It kind of swirls in and out. It's kind of fit with the style of showing retro video games. It kind of fit that kind of style. So normally I use glitch effects like I said before, but this kind of shows it keeps the same theme of retro games, because it's kind of getting more and more retro themed, this stream, of it being aimed at creating simple platform games. So they all tend to be the same type of effect. I think this is the same. This is another zoom in pan. So it'll zoom in and zoom out to the next effect, next screen. This is another one of those lower third text effects that was in the vlog titles, which is this one, text intro. So you can see there's a slight glitch on that as it comes in. I spent a quite a bit of time getting those just right to try and get like a certain style going on with each video. This is actually the voiceover. The voiceover, I put a couple of effects on here. I normally bump up the volume 6 or 12 dB depending on how I've captured the audio. Stick a limiter on. The limiter's got normally put about 5 dB of gain on, and I make sure the output level is minus 0.6 dB, so it's normally slightly underneath 0 dB. Normally you do -1 to -3, but I kind of like the text to be normalized. The voiceover to be normalized a bit louder to make sure that I can always be heard, but music tends to be normalized at a little bit lower unless it's like a proper produced music video, in which case it's all me. It's normally normalized right on 0 normally, because it seems to be a battle for who can have the loudest pop songs these days. So see, these are all individual segments which have been cut up from the original source video. There'll been a lot more junk on these. I think if I double click these, it will. No, it's a separate track. Normally I group groups of audio and video data, so I can cut them up as one section, but when I recorded this, it was a single screencast that was recorded. Then I cut up the screencast into sections, which made sense, and then I've done voiceovers for each section. So this is broken down into multiple different tracks. So you can see each of these is a separate voiceover section. So I think in total there's almost 70, 80 different voiceover segments that I kind of cut in each section. So this is a section all about creating the sprite, blah blah blah, and I'll kind of just record one section, and then that'll go down onto the track, and I'll play it back, make sure it fits. If it doesn't fit, I'll probably add freeze frames, modify it, or re-record the vocal track to make it fit again. You can see there's a ton of these that go into this as well. And I think that's about it I can show you. I just thought it was a nice insight into what it actually means when I make a video. There's a ton of stuff that goes into it that probably isn't immediately obvious unless you actually make videos. And the ending is kind of timed almost exactly the same. It kind of fades out with the you just play it. Next time. So it's all timed to the music as well, so it takes a bit of time to tweak the keyframes and the strobe animation on that to get it to fit. And then I always leave a chunk of 5 seconds at the end for the subscription and the YouTube cards at the end, so you can pick the next video and things like that. So they have to be a minimum of 3 seconds from the end. So I like my video to fade out to black. So that fades out to black with 5 seconds left, and that way the center playlists and things like that aren't overlapping the logo, because otherwise my logo's a bit too big to take into account the 3 sections that I overlay for the cards at the end. So it just makes sure it all fades out to black. And then I've got like a full 5 seconds, and there's like a 1 second transition to fade out, which will be a glitch strobe effect, which is that you can see there. The glitch strobe, so it breaks down my logo into 3 channels, red, green and blue, and kind of rips them out diagonally and creates that effect. So in a nutshell, that's kind of my editing process. I did plan on making a video I'll do that at some point, but it's going to be quite involved because I'm going to have to get my wife to help me to record me making the video, which is and then editing the footage will be quite fun. It's probably going to be a quite time-consuming video to do, so I'll probably have to do something really short. So anyway, I thought that was a good insight into this, and these are quite big projects as well. If I reveal the project in my Finder window, and have a look at the actual size of this, the last MonoGame episode. So it's 90 gigabytes, so it takes a ton of space on disk as well. I think these are all pretty big. 32 gigabytes. Some of these I've cleaned up the media, so they're a bit smaller. 45 gigabytes. So five gigabytes, that's quite a small one. So they tend to be quite big. I record all my videos at 24 frames a second because it's supposed to give it a more cinematic feel, like a film, which is normally 23.9 something frames per second. The camera that I've got is, I'll just grab it anyway. I don't know whether you can even see, but this is the camera that I use to record my face scenes, which is a Canon G7X. It's about £600. It's kind of nice, got a flip up screen. You can probably can't see this because my webcam's really small on the screen. I can't really adjust it because I've got the scene set on OBS. It's a really nice camera. Battery doesn't last very long, but it does pretty good quality, and you can flip the screen up so you can actually see what you're recording. But I have a tendency to stare at the screen rather than staring directly into the camera lens. So if on some of the latest videos, I've made a conscious effort to flip the screen down so I can't actually see it, so you're forced to stare into the lens. It's a tendency just to stare at the picture of yourself to make sure the exposure is right and those kind of things. But it looks better if you're looking directly at your audience. So that's Final Cut Pro, what I use. And I'm gonna, like I said, I'm trying to learn Adobe Premiere and Adobe After Effects to maybe increase the quality of the videos a bit more. The software tends to be a bit more reliable, I think. It's used more in the film industry and things like that. I have quite a lot of problems with Final Cut Pro. I can crash it. I think I've crashed it on every single video I've ever made, at least once per video. The video before the last one, I couldn't actually render any of the output because there was a problem with one of the video files inside the video that got corrupt, so I had to actually render everything out as ProRes, which was a massive file. It was about 200 gig, and then transcode the entire 200 gig file back to YouTube, which took forever. So it sent me back about a day when I was making the video. So now what I'm going to do is go through some of the prep that I've been doing for the latest video. So let's bring this console up, make it a bit bigger. Make it full screen as well. So let me see where I am. Templates. So at this point in the series, we're about ready to flip the screen so that it's no longer top view, but it's a side view platform game. So I've been toying with starting that. I've got the code to do it, but I've kind of been procrastinating and putting it off because it's going to be quite daunting to try and describe something mathematical. The thing that I've been using for this series is slightly more complex than a normal collision detection in that just detecting that two rectangles are colliding, which the maths for that isn't too complicated. But you can do a whole lot better by just increasing the complexity slightly and using something called the Minkowski difference, which basically calculates not only if two rectangles are colliding, it can do it in a relatively small number of calculations, and it can also tell you the difference and direction of the angle between them. So I'm kind of putting off recording that video, and I've been messing about far too much with the tile sets. So I've been looking at a desert tile set. I'll just find that out on my file system. I've been using this tile set. Which kind of looks like that. I think you can see that okay on the screen. It's kind of like a desert tile set. It's just a nice side platform view. But you can see by this that, well, this is an Adobe Illustrator file. And this is open source, but you can also get, well, as part of this, you get PNG tiles, which is everything is a single art asset. And if you're making texture assets, you kind of want to make them as small as possible. So this isn't a very efficient use of space because there's a border between each tile and there's quite a lot of white space. So I've been using a program called Crunch, which was the tile manipulation program which was used on the game Celeste, which was made with MonoGame too. And let me find where it outputs to. I forgot what I've called this now. I think I dumped it straight into my directory. Ah, there we go. So if I go back to this, make the writing a bit bigger. If you use a program called Crunch, which you can get from GitHub, I think you had been looking at my GitHub history and you'd found that, I mean, I'd asked this question and you pointed me back at the thing that I'd subscribed to, and this is that program. The Crunch takes the name of a directory to put the files in, and it also takes a list of folders, and it takes a size parameter, which is the -s, -v is verbose, -p0 is the amount of padding, -x is to produce an XML file, -t is to produce can't remember what -t is, -b, can't remember what t is, and then -b is to create a binary file. So if we were to run this, the verbose option gives you this list of things that it's done. So you can see it's gone through each of the PNGs in the tile folder. Trim force, I can't remember what that T option is. Trim? Trim, yeah, trim. So what trim does is it makes all the images fit together by using the alpha channel to trim off any excess pixels so you can fit more on the screen. So when you run that, you would get a PNG which looks like this. So you can see within that it's a lot more condensed. The pictures are being trimmed somewhat, and also there's no rotation on this. So if we do this again, lost my command. If we do this again but add, this is really bad for being able to see, make that a bit smaller. If I put a -r, which allows it to rotate things as well, it'll go back through and do it again. Shove that over there. If we bring this back up and look again now, you can see that some of the sprites are now rotated on the side because it's more efficient to store them. And we've also got things like, get rid of this. It's got hash of the file, which is Crunch just uses it to determine if the file's actually changed, so it saves on regeneration. Like if I do it again now. let's say it's unchanged because it's looked at the hash, the pitch is the same, but nothing to do. If we look at the XML, it's kind of fair enough. It's a typical XML, quite bloated in terms of repeated field names and things like that. It's not too bad. 3 kilobytes is quite big for that file, but the binary file, interestingly enough, is only 684 bytes, which is really small. It's like 5 times smaller, 4 or 5 times smaller. So it's probably worth writing a binary reader for this at some point. But I was interested to use, I use a program called hexfiend quite a lot when I'm doing emulator programming to analyze the bytes as hex. And I thought it would be really interesting to view it with hexfiend. So let's bring that up. Put that on full screen. Not sure whether it'd be. And if I open this up with hexfiend, see if I can make the writing a bit bigger. It doesn't like that. You can see the format of the file is, you've got desert0, which is the file name, which is these bytes here. And I thought it'd be really interesting to, there's a template which is brand new in the latest version of hexfiend. And I thought if you actually look at on GitHub, let's find this. Chevy Ray's got this on his GitHub repo. And you can see he gives a description of the binary format. So you've got an int16 of the number of textures, string for the name, number of images, image name, and then you've got all the various parameters, which are the same as what's in this XML file here. Got image, the name, x, y, width, height, fx, fy, fw, and fh, which is all the parameters to determine where the image is on the screen and whether it's rotated or not, which is 0 or 1. But seeing that in a binary file, like when you're going to build a binary reader, I mean, I'm not going to build one now, but I thought it's interesting to, I'm always looking for the next thing that I'm going to build is how would I determine if it was correct or not. I mean, building a binary reader would be interesting. It wouldn't take that long to do, but how do you determine if it's correct from this hex file? So I quickly built the other day, I built a template for this with, okay, this is TCL tool something language. So the interesting thing though is it plugs straight into hexfiend, and you can see the number of textures is that byte at the top left, which is 1, and you've got the name. And the good thing is that every one of these fields actually highlights where it is. Oh, excuse me. A bit of hay fever here. And if you look at the last file, you can see it highlights right to the end of the file, and you can see every parameter. So when we actually come to build a binary reader for this, it's going to be really invaluable to compare it against. And the language for this is very simple too. And if I bring this up on VS Code, see if I can find it. Right, we'll go back in hexfiend and I'll open templates folder, and we can just drag that into here. So this is what the file looks like as a TCL file, which is tool something language. It's fairly easy to understand. I mean, this doesn't cater for the fact that there might be multiple textures. because that basically just reads the number of textures, a C string for UTF coding of the name, a number of images, and while the file's not at the end, we create a section using the C string UTF-8, which creates the section name, which is these names you see here, stone, etc. They're all collapsed. And then you've got an int16 for the x, y, width, height, and one for whether it's rotated as well. And these all line up with this section here. So this looks almost identical to this. You just haven't got any of the while loops and things like that. So I thought that was quite interesting because it almost matches the TCL language description. So it could be that at some point, I know I'm digressing again, this is another thing to build, you could build a white space sensitive binary format descriptor, which could possibly compile down into TCL, and you could possibly load it into Hexfiend or the Windows equivalent program, and you could visualize the binary format, or you could plug that into VS Code and visualize it as well. I mean, you could build a VS Code plugin for this as well to visualize the file, which wouldn't be that much work either. So that would be an interesting project as well. So instead of doing the next video, this is what I've been doing. I've been screwing about with binary formats, textures. I've been finding the perfect texture for the platform game. So I need to stop messing about with this stuff and actually get on with describing the maths and things like that. So I've also been doing a lot of studying as well. I've been studying a lot of Rust, and I'm also going to start a bit of Clojure as well. I've been trying to do a bit of studying to level up my capabilities for getting new freelance and contract work, because there isn't a great deal of fsharp work about. So I've been looking a lot into Rust and things like that, and binary formats, and it kind of ties back into my love of emulating software and getting closer to the CPU hardware level. That side of things, it kind of works quite well. For me anyway. I was hoping there'll be maybe some Rust work coming up, and it's also interesting to do some Rust demos, like converting parts of what we've built here into Rust to see what it would look like, if it's more efficient, if it runs better, if it runs worse, if it takes longer to compile, it's less, and it's kind of nice to compare languages to see how one language fares against another in terms of usability. So I think with Rust it'd probably take me personally longer to build what I've built with fsharp, but it might run a lot faster, but it might run a lot slower. It might take me 10 times as long to build, and it might be twice as slow, or it could be twice as fast. So there's going to be various trade-offs, but it's going to be interesting to see exactly what they are. I think a lot of developers don't investigate fully because there's either not enough time, there's a lot of time pressure on projects, so you're kind of forced, maybe it's not forced, but you kind of stay within your comfort zone for efficiency, whereas if you get out of your comfort zone for a short amount of time, then efficiency might improve, or you might find an entirely different tool or platform which you like even better. So why not experiment? It's all part of the fun. So I really should have prepared better for the stream, but like I said, I've been really busy with a lot of studying and doing some interviews for work this week as well, so I haven't had a lot of time to even work on a video or anything like that. So I do apologise for this, but I thought this side of things would shed a bit of light of what I've been doing lately, and it might tie into a bit with what I've been mentioning with social media or on Slack and those kind of things, so you can see what I've actually been doing with this stuff as well. We saw what trim was, /t trim. I haven't removed duplicates, but there is no duplicates in these. But you could set. I don't know why you'd have duplicates. I guess you could have multiple sprite sheets where the artist has created the exact same texture, or maybe he's. Sorry, just distracted by. I've got YouTube live stream shown on left, so I can see if the stream's health and things like that. It kind of updated to this screen. So yeah, so this crunch program is quite good. It's really fast. It runs instantaneously. Gotta force this, it just instant. It's kind of like when I use Hugo to render my blog pages. It does each page in less than 2 milliseconds, and it's Hugo's kind of a blog engine written in Go, and it's super fast. It's 10-15 times faster than Ghost or some other JavaScript solutions, or Octopress, which is the one I used to use in Ruby. So I don't really touch Go. Programs written in Go can be really efficient, so I use whatever tool's kind of useful to me, to be honest. I kind of like languages in general, so it's good to play around with them from time to time. So now we should really do a bit of code, and I think we'll investigate more about where we got to last time. I'll bring up a new tab. Can't even remember where I've started everything. I think it's true. Go. Yeah, and then MonoGame 2. Was it MonoGame test Elm? I think this is where we got to last time. Yeah, I've heard of TCL before, but I've never really known what it was, but it's quite simple. It has a lot of other functionality like a normal programming language, but the thing that got me, it was so similar to the textual description of the language, apart from the while loops. It got me thinking that you could make a white space sensitive language, which would be perfect to produce from fsharp, and it would probably tie into something like type providers, or you could build a tool that kind of leverages part of I forgot what it's called now. Portal code. So it'd probably be worth investigating in the future to kind of describe binary formats like that. I mean, it's really easy with Erlang as well. The Erlang language is kind of like built in, so you can easily break a binary file down into pieces. Yeah, it would also work as a CE as well. That would work. You could probably make combinators for custom keywords. Is that what they're called? I think they are. For the different primitive types like C string and such like. C string is just a string that's delimited with null on the end of each part of the string. I had to actually ask it's called Chevy. I had to ask Chevy Ray about that because I couldn't tell how the binary strings would terminate, but he replied really quick. I'll give him a screenshot of what I've been doing, so I thought he might find it useful at some point if he's still using this binary engine. So yeah, luckily he replied quite quick. I think he replied within about an hour, so I could just use the C string to terminate the strings to see them. So if we run this, I mean, I can't remember all about what we were doing last time, but I thought I'd continue this off. I did do a little bit more work on it, and I got it to run. And I did a PR to Portal Code to fix the issue that we were getting. So we've got our blue screen. And then if I make this half screen, shove this to the right, and then is how you do it? I can't even remember. No, I think we need to do command line. FCS watch, FS live, send watch. Is that right? I can't remember. I think we need to launch it, then it connects. I think that's worked. I can't remember the keyboard shortcuts to do quad screens. Did I get this working? I can't even remember. Observable add. Let me see if there's Confile blue. I'm sure I fixed this. Maybe I didn't. Evidently not. Observable. Is this what we worked on? I can't even remember. It doesn't. It looks like it's right, but maybe it isn't. Elmish program. Can you remember what we worked on the last live stream? Maybe this is a copy of what it is. MonoGame 2. Watch. I hate it when you can't remember what you were doing before. I'm sure that it was different to this, because this is just the pure program. There's no actual content or packages or anything. MonoGame test Elm. I mean, this is Elm architecture. It was all. I mean, there's no portal code at all in this, so I think this is something I worked on before the live stream to prep to make sure it was physically possible. I can't remember. I mean, it doesn't work with this because because of portal code or Fabulous doesn't support events. So when we have something like when it interprets this file, there's an event subscription, and that will not interpret properly with portal code or Fabulous, which kind of ties into this extension of generic type needs FCS support observable member add. So there'll be an observable add somewhere in here. There we go. So these won't be supported with Fabulous or portal code. So this is going to be find the repo. I don't know where I put it. So I've got MonoGame 2345, logo, MonoGame test, I can actually go have a look in here. I've got MonoGame architecture in number 1, 2. And there's a ton of stuff in there. Must be MonoGame 1, I've done it. I don't even have a MonoGame 1. Where was that? Can't remember MonoGame 1. MonoGame test. So this looks trigger update, base update. This looks slightly different. Yeah, this looks more like it. So anyway, if we run this, something should happen, and we should be able to attach the watcher this time. So if we attach our watcher in our window up here, and then if we go down to our view function, wherever it may be, getting a bit lost in this code. go. Here's our view, steel blue. So if we change from steel blue to, I don't know, beige. Save. Yay! You got live update. We could go to Blanched Diamond. That's pretty cool that works. The thing that we had to do was in this live view, we had to modify this guy here. There was a, I think it's in the interpreter actually. This was missing. So last time we got an error that popped up to say that there was no such thing as a float 32. And because we're using lots of float 32s, it triggered the error at this point. It basically dropped down into a wildcard for our prim. So it's kind of it's trying to do something within here without actually running the correct conversion operation that would normally happen. So I don't know what it's doing, but it's trying to find. I don't actually know what this bit does. But anyway, I made a PR to fabulous, well, rather portal code. Git combo. So if we look at commits, you'll be able to see one of my commits in here, which is add our primitive float 32. So all we did was add one of these, but this fixed the bug. And this was because, like I said, it was dropping through into the wildcard right down below. So it's dropping into this branch of the code here. So I've done a PR to portal code and also to FCS watch, which references the portal code stuff, but he kind of has like a copy of the portal code. It doesn't actually include the portal code as a submodule or anything. It's kind of a complete copy paste. I think it's hoped that, I think Don Syme was hoping that the portal code would be end up owned by FCS watch instead, because it had a better implementation of watching. But I don't think Don has been active whatsoever in portal code for quite a while. Anyway, make this really small because it's getting in the way. And there's not a great deal we can do with this because I haven't got any of the draw code in. Just check the time of the stream. Kind of coming up to the end of an hour, so it can't start anything big. What we can do is keep looking at this for a bit longer, try and figure out where we are, and see if we can commit any of this code back in, because it's all sorts of junk in here. I think I've missed a git ignore off here, because this is horrendous. MonoGame 1. So I've made this from the MonoGame 1 repo from the live stream, and I've neglected to add any of the code back to the Elm architecture branch, which is bad. So what did I do? Proof of concept. So I never added any of this code back, which I thought I had done. Anyway. So what we can do in here, we've got sprite batch begin, player draw. So where's the player? There we go. You can see the player is drawn on screen, and it's quite clunky. Why is it so bad at updating? Let's have a look to see if I've done anything to make it this bad. or whether it's the performance of part of code or something like that which is bringing this down. Not quite sure why it's so bad. I mean, if this line here was enabled, it would be running at 6 frames a second, but it isn't. This should rerun that piece of code. It's not different. It should be 1 frame a second. That doesn't look like it's changed to me. That's a bit strange. I wonder. That's a problem with these fabulous projects and part of code stuff in general, is when you change something, how is it actually reflected in the actual running program? What's happened to the old code? Where does the new code get applied to, and what's happened to this? I mean, I've got this game app which is running. So this is never going to get rerun because the only part that gets replaced is the dynamic view part. So enable live update gets run, and this part gets replaced every time we make a change. Update and view get changed. But this part, although it's comprised and interpreted as part of this, it's not replaced. This will do nothing until we hit stop. And if we start again now, wait for it to spark up. Ooh. File not found. I'm sure we got this last time as well. So if we look inside here, I bet the content folder's disappeared. Yeah. Oh, annoying. I don't know why it does this. It's really annoying, especially when there's hundreds of these files. But this thing here has disappeared. Rerun now, it should get included. So now, this should be running at 6 frames, no, 1 frame a second I think we set it to, and it should look really awful. Can't even get to appear on the screen. Get rid of this, there's no space. Yeah, I can't get anything to appear. And that's not updating either. It is attached. Waiting for changes. Okay. Sky blue. Not updating. I wonder why. Get rid of this. Start it up again. So why is that so clunky? The live update? I don't know whether you can notice that on the screen, but it just doesn't look good. Jerky. Nothing running on debug console. It's running at 73%, which is weird. Maybe that's my VS Code. No, it definitely was that one. It's running at 70% just to draw one skeleton on the screen. That seems a bit iffy to me. Well, this should work at 6 frames a second. Try 15 frames a second. And is it because we're moving the sprite by a fixed amount each time? We're moving it by position plus the movement vector times the speed times whether so it's relative to time passed. So the longer the update interval, the more it'll move. That's not how it's behaving though. I mean, because if I stop this and make this 5 frames a second, and run this, yeah, that's definitely behaving correct now. Because that's truly awful. I mean, we've gone back to 1981. I'll change this to 120 frames a second. It should be silky smooth now. That's awful. It's something seriously fucked. And this should be 120 frames a second. That should be really smooth. Yeah, I don't think this is a feature. There's something seriously wrong with it. I mean, if you're updating it, this should be 120 frames a second, so it should be silky smooth. Particle code's attached. I'm wondering if the particle code attachment and the interpreter really slows things down. Because you've seen 70% CPU, and the CPU usage for a MonoGame project should be a few percent. It's shite. Am I typing this up right? That's 1 divided by 120 times 1 from seconds. 125th of a second. I mean, that's right, but what's going on? Kill this. That's still crap, but run it again. But I won't connect the live thing. Silky smooth. Check CPU. 6%. So, this baby is screwing up the CPU. So the CPU usage is going from 3.9%, with 3/4 of the screen occluded. Now we're at 18%. Hasn't even done a single update yet. 100%, it's just done a single interpret. Constantly on 100. There's pretty much something seriously wrong with this, because we're updating at 120 frames a second. CPU's at 100% as a single sprite on the screen. And if I put a breakpoint in the update function, I'll need to get access to game. Game here, yeah. So put a breakpoint in here. Boom. Right. If we look at the game properties in the debugger, is after fixed timestamp true, context draw update, graphics device. Trying to look for a is running slow parameter. Can't even see that one exists. I know that it does somewhere. Where is it? It's not on graphics device. It's active, it's fixed times, mouse visible, true. Draw, non-public members. Initialize true, platform. Drawables, initialized. Maximum elapsed time. Go back to the Elmish program. Game 1. No, it must be in here somewhere. Elmish game. If we go to this. So now we're in the base class. Have a look at some properties in this. Yeah, the performance was okay, but I know that it works fine as a standalone application. There's nothing wrong with the event loop. It just draws it. There's nothing to do. It should be practically zero CPU. I mean, there's going to be some CPU because we're drawing one sprite and we're clearing the screen every time, but it should be less than 5%. Otherwise, you're basically screwed before you started, because MonoGame wouldn't be suitable for anything. But as soon as we start attaching portal code, it's slowing it down to I don't know if it's a ratio of slowness compared to the frame rate. It's hard to tell what's happening, to be honest. I just wanted to see if the update loop was getting a notification that it was actually running slow, because there should be a parameter to say is running slow, because then in your update loop you know that frames might have been skipped. So that's kind of what I'm looking for. Because if I know that frames are being skipped, then if I know frames are being skipped, then I know that there's something wrong in the update loop. Update frame lag. That's quite high. Suppress draw false. I can actually see what I expected to find. Expected and is running slow. Property somewhere. Okay, we'll get rid of this. Go back in the program. Kind of kill that. I don't know why it's running so slow, but definitely. And that should be 120 frames a second. 60 frames a second is normal. And I thought this was actually a promising demo, but if the performance is diabolical, then it's no use to anyone. Silky smooth. Well, it kind of is. And that's 60 frames a second. Let's look at the CPU. 27%. So where's the CPU going? So I use 72%. There must be a loop active within portocode which is consuming CPU unnecessarily. In VS Code, I'm not sure we can actually profile this. I mean, where's that 70% going? I wonder if you can use instruments. I was going to try attaching with instruments, but it's trying to get the process list. I don't know why it takes so long. I don't know if we'll be able to determine where the resource usages and from this. Hell of a call graph though. Let's have a look. This stack trace is pretty much unreadable for me. Lots of globalization native starts with. Hard to tell from this. Oh, come on. I think if we were on Linux, we could have got a diagnostics dump of the performance usage, I think, but on the Mac I don't think there's anything for .NET Core, which is really crap. Last I checked there was no lead time on when they'd have that done, which is really disappointing. It's consistently using 70% CPU, which isn't right, so there's something running, but I can't tell what. Got lots of threads. I can't tell what any of the threads are doing now. Resolve type. A sec. I'll put breakpoint on this. That's getting constantly called. The stack's quite deep, and it's coming from so hang on, so it's running context run. What I think's happening is the event loop which we plugged in for this is running super fast, well, as fast as it can on every update, and that's consuming the CPU and causing the slowdown. So the more updates called, the more this context run is run. So therefore, the greater the frame rate, the greater the resource usage. That kind of ties in, that kind of makes sense now. So this context object was a custom synchronization context, which somebody suggested this to me from Twitter, I think. So it's this type here. So basically for portal code to be able to run your code, you need it to run on some kind of UI loop, on the event loop that the application's running in. But MonoGame has no event loop. It just runs. There's no synchronization context because MonoGame isn't running on Windows Forms or WPF, so there's no synchronization context loop running. So the issue is this run loop is posted to every time an update occurs, and it looks like this is what's consuming all the CPU time from a quick glance. So every time there's a frame update, this will be called. So what could be done is to build a better synchronization context for this version of Elmish MonoGame, which is not something I want to spend my time doing, to be honest. So what happens is, let's have a look in, I'll just stop this for now. Let's have a look at the code. What happens is, go back to the Cyanide view. So this context is used whenever we need to get back to the UI thread. So the context is run in the update loop. So every time the update loop runs, we need the context to possibly run, because this begin invoke on main thread, whenever that's called, it switches to the synchronization context, which is this context, and it schedules an action to start. So whenever we're using this, which we can see down here, it's on whenever our main dispatch loop function runs on that context. So whenever we process a message or whenever we update a view, actually, whenever we the dispatch loop, anything going on the dispatch loop gets invoked on the main thread. Because this begin invoke on main thread is that switches to the context and executes the action. So that occurs when does the dispatch loop happen? Whenever update occurs. So it gets quite fiddly because there is no proper synchronization context. I haven't built one, and the one that I am using is one that was kind of slapped together really quick. So we've got a lock object, local run, the post callback. So we basically lock, execute, and run. Local run, post. Can't even remember what this does, that's the problem. No, so it's whenever we're posting, we're accumulating to the list. So we're appending one on to the list every time. And then when run's called, it grabs the current list. Or we create a lock, and then we copy our to run list to local list, and the to run list gets erased, and then we run the local lists that we just grabbed. We get the delegate to run and the state for each one, reverse them because they're in reverse order because we've used append here, and then we run each one. We invoke each one. So I think this is the part that's taking too much time. So we probably need a better synchronization context, because when part of code is not attached, this isn't happening. But when it is, it's causing this issue. Why would that happen then? So that's 60 frames a second. For the sake of it, we'll run it at 200. To be in this one. The INI debug task just doesn't work for me. It's always broke, so I always use my own custom debug task. So this should be 200 frames a second. So that's fine. CPU 6%, attached FS Live. %, 4.4. Whoosh. CPU's been eaten now, 100%. So one core's constantly using all the processor. Yeah, perf is diabolical now, because that update load's been hammered. Yeah, half a frame a second now, rather than 200. Kill it. The CPU is still crap now that we terminated it. I guess it's running. It's still running that loop trying to execute. I think what we'd need to do is to re-engineer the way Elmish works so it wasn't using that synchronization context, or we would write a different synchronization context that was more efficient. But as the synchronization context stuff is, it might be difficult to get right. It may be that we can just borrow one from Windows Forms or WPF in some way. I don't really want to spend any time doing that kind of thing, because I want to spend time actually building the game part. So it's fine to experiment with things like this, but you could end up spending all of your time building hot reloading loop rather than actually building your game. So it's not something I want to get involved with, but kind of the part of me which likes to solve problems is thinking, how can we solve this? It's tricky. What's the time now? That's 6:15. Time to be start about 4. I'm going to call it a day in a minute, and we can I don't know. I think I'm going to leave it here, and we'll look at fixing this at a later date. It's going to bug me, so I'm probably going to have to look at it at some point. So anyway, I'll leave the stream there, and thanks for tuning in, and I really appreciate your support, and I will see you in the next video, and bye for now.